So this is a graph of the velocity of a particle traveling on the x-axis from time 0 until time 7. So if we're going to interpret this graph, there are all kinds of things we can tell. If I was wondering, when was the particle moving to the left? Well, I know that it moves to the left when the velocity with respect to time is less than 0. So that is when the graph is below the t-axis. So that starts at 3 and ends at 7. So it's going to the left from 3 to 7. It'll be moving to the right when the velocity with respect to time is greater than 0. So above the t-axis. That starts happening at 0 and ends at 3. So what if I was asked about the particle's acceleration? Well, I know that the acceleration will be positive when the slope of the velocity is positive, because acceleration is the derivative of velocity, the slope of velocity. So you will have a positive acceleration from 0 to 2 and from 6 to 7. And I know that because v of t is increasing. A negative acceleration will be when the slope of velocity is negative. So I know my justification will be v of t is decreasing. And I look on the graph, when is the graph decreasing? From 2 to 4. Which makes you wonder, okay, what's happening from right here to right here? Well, my acceleration is 0. My velocity is constant, so the slope of the velocity, the acceleration, is 0. So it's not changing speed. So then you might look and say, okay, what's happening at t equal 2? Well, from 0 to 2, the particle was speeding up. The velocity is positive and increasing, but from 2 to 3, the particle is slowing down. The velocity is still positive, so he's moving to the right, but the velocity is headed towards 0, so this would be slowing down. So it was speeding up until t equals 2 and slowing down after. One way to see speeding up and slowing down is just to look, is the line approaching or going away from this axis right here, the t-axis, because this is when velocity equals 0. So the particle is speeding up because it's going away, slowing down, headed towards a velocity of 0. From 3 to 4, the particle is speeding up because it's headed away from a velocity of 0. No, it's speeding up in the negative direction because it's below. Right here, it's not speeding up nor slowing down. And then from 6 to 7, it is slowing down. It's headed towards a velocity of 0. So I could say it was speeding up from 0 to 2. And I know that because v of t is positive and increasing. This handles the acceleration issue. So velocity and acceleration have to have the same signs for the particle to be speeding up, and they do. If it's increasing, that means the derivative of velocity acceleration is positive. So speeding up from 0 to 2. From 2 to 3, the particle is slowing down. And I know that because the velocity is positive, but decreasing, which means the acceleration is negative. If I look at from 3 to 4, you can see that it's headed away from a velocity of 0, so it's speeding up. But I can't use the same justification, because v of t is not positive, nor is it increasing. So I'm going to say v of t is negative and decreasing. Okay, from 4 to 6, it is neither speeding up nor slowing down. The velocity is constant. But from 6 to 7, it's headed towards a velocity of 0. It is slowing down. And I'm going to say v of t is negative, but increasing. So velocity and acceleration are working against each other. Now, when does the particle turn around? Right here at t equals 3. Because it changed from going to the right to going to the left. It achieved its maximum position at t equals 3.